Hey, so some of the things I've been playing with over the summer include getting familiar with Jupyter, Jupyter Notebook and Jupyter Lab, and I decided to learn that by making a cell matrix kernel. So I've done that, and I've put it up on Binder, and so I'll put a link to it in the description. But basically, this is sitting in a container off on a server, and depending on how recently somebody has run it, it may take a really long time to launch, or it may launch fairly quickly as it's doing here. And this is totally self-contained, and it's basically a cell matrix simulator that you can just sort of mess with through the interface of Jupyter Notebook, Jupyter Lab. So I'm going to turn off the simple interface and start a new kernel for cell matrix. And when you first come up, it brings up a tutorial, but I want to just kind of show you some of the features initially. So I can initialize the matrix, and so Jupyter, if you're not familiar, you do Shift Enter to run a cell. So that initializes a one-by-one matrix, and I can ask for a picture of it with a pick command, and there it is. And we can use various commands to modulate this cell. So I can say set data west, and that turns the data west input to 1. And if I ask for a picture now, I'll see that line is thick coming in from the west. So it's actually set an input, and I can clear data west. And if I do a picture, I can see that line is thin again, so the input is a 0. If I ask for a truth table, the truth table is initially completely empty, but I can compile a new truth table and say, for example, data east equals west, data west equals east. And if I run that, and now I look at a truth table, I can see there's some 1s in there. And if I say display the contents of that equation in terms of the contents of that cell in terms of equations, I can see east goes to data west, west goes to data east. So here's the picture of the cell so far, and if I say set data west and I look at a picture, we can see that that input from the west has gone to the east. And similarly, if I say set data east and then I look at a picture, I'll see that the eastern input has transferred over to the west. And so this is, a basic one-cell setup. If I say compile, and let's just say data east equals not west, then if I look at my picture, since my western input is 1, my eastern output is 0. If I clear data west and I look at a picture, western input is 0, eastern output is 1. So you can create cells like this and so on. You can do a question mark to see a list of all the commands that are available. So we can initialize a matrix with whatever dimensions we want. We can set and clear inputs. We can look at truth tables, compile a truth table. We can look at the outputs or the inputs of a cell using the outputs or inputs commands if we don't want to look at a picture. Disassemble a cell. If we play with C mode, we can tick the clock by using the tick command, and we can turn on single step mode. I don't know if that's actually enabled yet. We can also turn on an auto pick mode so that every time we run a command we get a new picture, so you don't have to keep typing that. So I can say clear data east, and it clears that input and shows me a new picture. I can say set data west, it sets it and shows me a new picture, and so on and so forth. If we initialize our matrix to be bigger than just 1 by 1, we need to specify rows and columns. So I could say, for example, compiles cell 0, 0, let's just say data east equals west, and then compile 0, 1, let's say data east equals west. And I'm just going to do this all the way across the top row, so that each of these is basically a little piece of a wire. If I look at this cell 0, 3, it shows me it's going to take what comes in on the west and goes out to the east. So now if I say set 0, 0 data west, I have a 1 coming in here and it goes all the way across. And if I clear 0, 0 data west, I've got a 0 going in there and a 0 comes out on the right side. So we can play with all of these commands. There's help available. If I type a double tab, it will show me how to complete something. If I type, for example, a C and I hit a tab, I can do either clear or compare or compile. Those are the two options. If I type something and it doesn't know what it means and I hit double tab, there's no completion. If I do a shift tab, I'll see a list of help options. And if I type, like, you know, COM for compile and I do a shift tab, I get a little blurb showing me the legal syntax for whatever command I've started, so the compile command. So there's context specific help and so on. And as I said, when you first run this, it brings up a tutorial which just kind of tells you about the cell matrix. This is not finished, but I've got most of the first few sections done. So it talks a little about Jupyter, getting help, list of the available commands, basically what a cell matrix is, a little bit of background, links to the old patents, how this tutorial is organized, and then it's a mix of, you know, descriptions of what's going on and then cells that you can actually, you know, interact with if you want to play along. This will initialize a 4x3 matrix, but we'll stick with a single cell, so we'll do a 1x1. Here's a picture and so on. So this goes through you know, basic examples of working with a single cell, setting inputs, looking at outputs different ways, and then setting up a truth table, kind of like we just did, some shortcuts, building some wires like we just did, and then it starts building out logic circuits. So there's the inverter again. Here's a single bit adder, and we can see the equations and run some tests and do some simple single bit addition, and then we can move on to 2 cell circuits. So here's a circuit with 2 cells, and here's a 3 cell circuit. We've got longer wires, and then playing around with single step mode. So yeah, that is implemented, so we can actually see how inputs move through a collection of cells one step at a time, whereas normally when we just change an input, all the corresponding consequences of that happen at once. We can run it in single step mode. Here's an example of a simple D-latch, and then multi-cell circuits. So a 3-bit adder, which is just, you know, 3 1-bit adders side by side. So we'll play around with that a bit. And then the fact that we can read binary grids from a loader tool, which is available in a Docker container. That was a previous video that I did. And so here's an example of a 4-bit counter made out of toggle flip-flops, and you can see it counting in here. You can see the equations and so on. And then chapter 5 we start talking about C mode, and so this explains, you know, how we program cells, the whole dual nature of the inputs and outputs, where they can be data in D mode or code in C mode. And you know, if this is all new to you, you'll probably want to do some reading on the cell matrix outside of this if you want to understand it. But then you can also use this framework to, you know, read along and actually run some experiments, and then, you know, try different things, right? Because this is the best way to learn something new, is to experiment. Well, this is a nice little platform for doing experimentation. So we get into cell copying, and we make a nod to the notion of multi-cell operations, Medusa circuits. That's as far as I've gotten on the demo. But we would eventually talk about compiling truth tables into memory, pumping them into an input, and then doing wire building. At this point, though, I am starting to think that I'm going to re-implement this using a plain old Python kernel, and take the old wire building Java classes, convert those into Python and make them available, runnable in the Python kernel, so that we can do experiments with building wires, extending them, making turns, breaking wires, and things like that. So that's going to be a whole nother series of videos. But anyway, this is a simple cell matrix simulator in Jupyter Lab, available for experimentation right now. Alright, next video I'm going to talk about the cell matrix fabric a little bit.